All right, this is the fourth SLO problem. And in this problem, we want to um, look at the skills that you have developed regarding hypothesis testing. All right, the problem reads, a light bulb manufacturer guarantees that the mean life of a certain type of light bulb is 750 hours. Because of product redesign, he believes that the life of the light bulb has increased. If a random sample of 36 of the redesigned light bulbs has a mean life of 759 hours with a standard deviation of 60 hours, test the claim that the average life of the light bulb is more than 750 hours. All right, so read through the problem. I'm not going to get overwhelmed with the details. The first thing you really want to focus on is what the problem is asking you to do. And in this case, we're asked to test the claim that the average life of the light bulb is more than 750 hours. So we would write that in our notation as mu is greater than 750. And because this does not contain equality, this would be our alternative hypothesis. The null hypothesis is going to be that mu is equal to 750. Okay, so now that I have my hypotheses, I can use either a traditional method or um, a p-value method to do the test. I'll demonstrate both. Okay, with the traditional method, now that I have my hypotheses, the next thing I have to do is set up my rejection region. And so here, this is going to be a right tail test since we have a greater than alternative. And so this is my rejection region, and it has an area of 0.02, which is the alpha value that they've asked us to use. Okay, now I need to think about, before I get my critical value, which separates the rejection region from the non-rejection region, I need to think about the type of test that I'm going to do. And in this case, since the standard deviation that we have is based on the sample that they've given us, we don't know sigma, and we're doing a t-test. So I need to know the t-value that separates the rejection region from the non-rejection region. And I can get that information from my calculator. So on the calculator, I'm going to go to second vars, and I'm going to use inverse t, number 4. Okay, and the syntax is the area to the left, with which if alpha is 0.02, then our area to the left is 0.98, followed by a comma, and then I need to tell it the degrees of freedom, which since my sample size is 36, my degrees of freedom will be 35. And so it gives me my critical value, which is 2.133. Now, what that means is if my test statistic is greater than 2.133, I'm going to reject the null hypothesis. If it's anything less than 2.133, then I'll fail to reject the null hypothesis. Okay, so let's find the test statistic. Again, I'm going to use my calculator for this. So we've already decided that we're doing a t-test. So I'm going to go to stat, test, select number 2, which is t-test. Okay, make sure that stats is highlighted. Okay, our null value, which comes from the hypothesis, is 750. Okay, our x bar is from the sample data, and that is 759. Okay, our sample standard deviation is 60, and our sample size is 36. Okay, then we choose the sign that matches the alternative hypothesis. This isn't so important with the traditional method, but with the p-value method, this step is very important. So I've highlighted the greater than option. And then I'm going to arrow down and say calculate. Okay? So my test statistic comes out to be zero point 0.9. Okay, so my test statistic, and this is what I call the witness. It comes from the sample data, and what it actually does is we've computed um, a t-score to help us determine how likely it was that we would get this sample mean of 759 if the actual mean is 750. And according to this, it's not that unlikely. Okay, we got basically think of this kind of as a z-score, except it came from our t-value, and so it's not unlikely, and it certainly when we compare it to our critical value, zero point 0.9, remember there's a real number line under here, zero point 0.9 falls somewhere over here, which is in our safe region. So we fail to reject the null hypothesis. Okay, and remember the alternative was our claim, so we would say the sample evidence does not support the claim that the mean of this new light bulb is more than 750. Okay, now if we were doing the p-value method, I would have just kind of left off all of this information except for the hypothesis. You have to have a hypothesis, but then from there we can just about go straight to the calculator and do exactly what we've already done, except we didn't take note about this. This is the p-value, and basically it looks at the same information just from a different angle. What's the probability of us getting a sample mean of 759 or more if mu is equal to 750 from the null hypothesis? Well, if the p-value comes out to be small, that means that the sample evidence under the assumption of the null hypothesis is rare. The problem is we're holding this rare, quote unquote, rare evidence, which makes us think that it's not so rare. And so we decide if this isn't rare, but they say it's unusual, there must be something wrong with our null hypothesis. All right, so all of that is to say that a small p-value is a red flag. Okay, keep repeating that to yourself. A small p-value is a red flag. Well, how small? Well, if the p-value is less than alpha, then it's small enough for us to be concerned. So in this case, our p-value was 0.18, but we know that alpha is 0.02, so it's not smaller than alpha. All right. So still, we fail to reject the null hypothesis since p is greater than alpha. Okay, our p-value I think was 0.18. Our alpha value is 0.02. So our sample data is not unusual under this assumption. We failed to reject the null hypothesis. Now, you would want to report exactly what the p-value was. It was 0.187. Okay, and compare or justify why you're choosing to reject it. And again, it's because, or rather in this case, fail to reject it because the p-value is um, larger than alpha. All right, so as far as the test goes and how we'll evaluate the question, certainly I'm looking for hypotheses. You can't do a hypothesis test without having hypotheses. All right, and then from there, I mean, because most of you will be taking this on the computer, so you can't really draw out this curve. I'm not expecting you to do that, but you do have to report what your critical value is and also your test statistic if you're choosing to do this by the traditional method. Or you can report your p-value and then compare it to alpha, and then clearly state your conclusion that we're going to fail to reject the null hypothesis, And then it helps if you finally say what this means in terms of the claim. All right. And again, for us, since we failed to reject the null hypothesis and the alternative was our claim, we would say that the sample evidence does not support the claim that the mean is greater than 750.